Hello guys, welcome back to the channel. Today we are going to solve this problem. This question was also asked in civil service main exam in optional paper of mathematics. So we need to calculate the value of a and b from this given expression. Here limit x tends to 0 and we're given some function which is in indeterminate form 0 by 0. Let's use the Maclaurin series expansion for sin x and cos x. Let's start. We know sin x is given like, right? If you don't know this particular Maclaurin series form in this pattern, right, then you might be familiar with what we get after expanding this, right? If you put n equals to 0 over here somewhere, you'll get minus 1 power 0 is 1, right? X power 1 and everything remains 1, right? So you can solve this. If you place n equals to 0, you'll get x. Similarly, if you place n equals to 1, you might get minus x cubed by 3 factorial. If you expand further, you'll get plus sign here, okay? Because n equals to 2 means minus 1 whole square will give you plus sign. So it will be x power 5 by 5 factorial and so on, right? You might have read this expression of sin x, which comes from this complex representation. No worries, you can know any one of them. The complex form is sometimes useful. The expanded form is useful here, okay? Similarly, we have cos x equals to summation n equals 0 to infinity minus 1 power n by 2n factorial x power 2n. Expanding this like previously, we will get 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. Here the negative and positive sign comes alternatively, okay? Minus plus, they simply repeat because we have minus 1 power n in both the expression of sin x and cos x. Now we are going to use the simpler expressions in our solution. Now what we are given is limit x tends to 0 x times 1 plus a cos x minus b sin x divided by x cube equals to 1, right? This is our given expression. Now let's replace all that series expansion form of sin x and cos x here, okay? So limit x tends to 0 x times 1 plus, let's use big bracket here, a times, let's replace cos x by this expression, 1 minus x square by 2 factorial x power 4 by 4 factorial and so on, right? And minus b sin x is x minus x cubed by 3 factorial. The interesting thing is sin x has all the odd powers, right? And cos x has all the even powers. So x minus x cubed by 3 factorial plus x power 5 by 5 factorial and so on. And this whole is divided by x cube which is equals to 1. If we arrange the coefficient of x power 1, we get 1 plus a minus b times x. From this part, we get plus b by 3 factorial. From here, we get minus a by 2 factorial, which is the coefficient of x cube. Similarly, if we arrange coefficients for x power 5 from both of this side, we get a by 4 factorial minus b by 5 factorial x power 5 and so on, whole divided by x cube. Don't forget this limit is also for x cube, okay? Let's divide the expressions by x cube. So we get limit x tends to 0. We get 1 plus a minus b by x square, and we get b by 3 factorial minus a by 2 factorial plus we get a by 4 factorial minus b by 5 factorial x square and so on equals to 1. Now, if we use the limit for individual expressions here, the limit won't work for second expression. The limit will vanish all the expression after third terms because we have x power 2 and higher powers of x's here. This is not the indeterminate form, so this will vanish out. All the expressions after the third term will vanish. Let's not use the expression limit for the first expression. Let's write limit x tends to 0, 1 plus a minus b by x square plus we have the second part b by 6, 3 factorial means 6, minus a by 2, and remaining every other vanishes. It gives you 1. As per our question, this limit exists. That means the first term somehow must vanish, right? Because we have only 1 here on the right hand side, RHS, a constant. So we have a constant here, and if we use x tends to 0 here, it will give us infinity, right? This expression will become infinite. So let's not try to solve it. Let's simply assume that this limit must exist, and we do not have anything here related to x. So let's equate this to be 0. One plus a minus b should then be 0, right? Because we cannot use x equals 0 here. It will become infinite. But if we have this 0 by 0 form, then there will be possibility to have some limiting value. So let's say 1 plus a minus b equals to 0. In fact, this is not the assumption. This must be 0 if this limit has to exist. From here we'll get a minus b equals to minus 1. Similarly, the constant part will give us b by 6 minus a by 2 equals to 1. Solving, we get how much? B minus 3a equals to 6. So this is the second expression. If we add them, equation first and second, b will cancel out. So we get a minus 3a equals to minus 1 plus 6, which will be minus 2a equals to, minus 2a equals to 5. That implies a equals to minus 5 by 2, and b will be equals to a plus 1, right? A plus 1, that's minus 5 by 2 plus 1. This will be minus 3 by 2. That is our answer. Hence, a equals to minus 5 by 2 and b equals to minus 3 by 2. That is our answer. Thank you for watching the video. If you have any confusion regarding anything within the solution, please comment and let me know. Thank you.